Hello everyone, my name is Jorge Isaac, and today we will present our progress on chapter 8. My teammate is Isaac Ramirez, so this chapter is titled High Pass Filter and Feature Detection. In the previous chapter, we use low pass filters to blur image and remove noise. Today we are doing the exact opposite. We are using high pass filters to find sharp changes in pixel intensity, which allow us to detect edges, sharps, and corners. So, first we calculate the spatial derivation of our image using Laplacian and Sobolev operations. These filters highlighting areas where the colors transition rapidly, which mathematically represents a physical edge. However, basic filter can be very noisy. To fix this, we implemented the Canny Edge detector. So let's move to the Canny one. Canny is a multi-stage algorithm that applies a Gaussian blur, calculates the gradients, and uses hysteresis thresholding. So as you can see, the result is a perfectly continuous single pixel outline of the objects without the background noise. You can see it's too blurred, but I think I can make a zoom so you can see. As you can see, it's the lines of the image and it's too well represented. So let's continue. Once we have our edge, we need a computer to understand what shapes those edges from. We achieve this using Howth transforms. The standard Howth algorithm maps the edge pixels into mathematical Boolean space to detect perfect circles and straight lines. However, the standard line detection often tries infinite lines across the entire screen. To solve this, we implement the probabilistic Howth transform. This upgraded version calculates the exact starting and ending coordinates of infinite line segments, which is more efficient and precise for recognizing physical boundaries. So let's see. So here we have one line, and maybe the circles are not perfect, but it tries a little bit. I hope with the speaker more. If I put light, yeah, there we have. So there we have the lines and the circles of the speakers. So let's continue. By combining edge detection, geometry transfers, and high-speed corner tracking, we now have the computational framework necessary to recognize and track structured objects in real world. So thank you, and let's go with my teammate Isaac to see a little bit of the book. So let's see you there.
The book teaches about high-pass filters. These filters are very different from the last chapter. They do not blur the picture. Instead, they find the sharp change in light. This is how the computer finds the borders of an object. Next, the book explains how to find geometry. The author shows a math tool called the Hawk transformation. This tool is very famous. It helps the machine to find perfect straight lines and circles in the real world. Finally, the chapter talks about corners. A corner is a very strong point on an object. The book says that finding corners is the best way to track an object, then it moves in a video. In conclusion, chapter 8 teaches how a computer stops saying simple colors and starts saying real shapes. Thank you for your time.